right, today we're going to do a quick review of the graphing the parent parabola, understanding its behavior as opposed to using tables. And then we're going to use that same strategy to graph from the vertex form of a quadratic equation. All right, so here's our parent parabola, f of x equals x squared, otherwise known as y equals x squared. All right, because nothing is added or subtracted after the x squared, we know the vertex is at 0, 0. So I'm going to put V for vertex at 0, 0. Right there we know our line of symmetry is going to be x equals the vertex value of x, which is 0. We know that because this is a positive a, which means the coefficient in front of the x squared is positive, that it is going up, so its direction's up. And we also know that since it's going upward, we have a minimum value, and the value is the y from the vertex. So all of this information is gotten before we can even graph it, right? So that's pretty nice. So we have our vertex at 0, 0. Now, remember, understanding how parabolas work, whenever we move along the x-axis left or right to go to a next point, remember we always move left or right along x, then we go up or down for y. When we move along the x-axis 1, we're always squaring that x, so that means we go up 1. So if we move 1, we square 1, which gives us y, means y is 1, so we go up 1. So right 1, left 1, up 1. If we move 2 away from the vertex, always from the vertex, we square 2, and we go up 4. 1, 2, 3, 4. Okay, if we square 3, we move 3 left or right, we square 3, we go up 9. 5, 6, 7, 8, 9. And that gives us a really nice parabola, okay? And don't forget to use symmetry on one side or the other, depending on which side you graph first. Arrows at the top, and that's our parent parabola. Now we base our shapes of all our other parabolas on this. So remember, it's right 1, up 1, right 2, up 4, right 3, up 9, right 5, up 25. And then we use symmetry on the left side. Again, we're moving left 1, up 1, left 2, up 4, left 3, up 9, etc. Okay? So every parabola will then be compared to the parent as far as its shape. So we're going to just leave that there for a few minutes. Now, vertex form. Okay? Vertex form is important. We have a list of rules, pretty much what we've been using. Okay, and I'll put this back in a minute, and let's switch sides. So here's our rule. Vertex form is f of x, or y, equals a times the quantity of x minus h squared plus k. All right, the vertex is the h and the k value. Now, it's always x minus h, so you're taking the h without the minus sign. So I always say whatever you see inside the parentheses for the sign minus h, you only take the opposite of what you see. So if this said plus h, you take a negative number. If it says minus h, you take the positive of the h. On the outside, the plus k affects the y. So that is the y value. Okay, so that's it. And it's exactly what you see outside, including its sign or operation. Okay. Now our a value, just as always, our a value is still going to give us direction. So if it's negative, okay, then it's going to be down. If it's positive, it's going to be up. Okay. The a also gives you the shape. It'll tell us the shape. If it's 1 or a negative 1, because remember the direction is going to be the sign, so we're going to ignore the sign once we know the direction. We're only going to look at the absolute value of that number a. So if the a value is equal to 1, absolute value now, without the sign, then we know it's the same shape as the parent, which means you go to your vertex, right 1, up 1, right 2, up 4, right 3, up 9, and use symmetry on the left. Okay. If the a value is between 0 and 1, so it's a fraction between 0 and 1, again, ignore the sign because that only gives us direction, then it's going to be a wide, okay? It's going to be a very wide parabola compared to the parent. And the shape will be narrow if the a value is greater than 1, again, ignoring the sign, okay? And that's what we're going to use, all right? So Min and max points are gotten the same way, and so is the line of symmetry, all taken from your vertex. So really it's a matter of where A is located, still in front of the squared term, but our squared term looks a little different. All right, so I'm going to keep these directions here, and we're going to start our first problem. All right. So our first problem is f of x, or y, equals the quantity of x minus 3 squared plus 2. You are not going to multiply this out. It's not necessary. So our vertex we know is hk. All right, so let's set up a template here, okay, where we have y equals a x minus h squared plus k. Well, as you can see, the a value is 1. So the a is 1, which means our direction is up because it's positive. Now we want to get our vertex, so we're going to look and see what's in h's position. So literally you're going a is 1, parens, x minus, and what's in h's position is the 3. So our vertex x value is 3. So like I said, it's always the opposite of what you see inside the parentheses. I see minus 3, so my vertex x value will be positive 3. Now, my k value is exactly what I see out on there, which is positive 2, and that's our vertex. Once you have your vertex, all else is the same. Now, the a value, because it's 1, also tells us that the shape is the same as the parent, which means right 1, up 1, right 2, up 4, right 3, up 9. Okay, that's the cool thing about this. So let's go. Our vertex is not at 0, 0 anymore. It's at 3, 2. So let's go 1, 2, 3, 1, 2. Now, since the shape is the same as the parent, from the vertex, let's move 1 to the right, square it, and go up 1. Use symmetry on the other side. Go 2 to the right, square it, and go 1, 2, 3, 4. And use symmetry on the other side. We don't have enough room for 3 to go 9, but we only need 5 points for a decent looking parabola. And we sketch it out, arrows at the top, and we're good. Now, because it goes up, we have a minimum value. And that minimum value is the value from the y. It's on the vertex, so it's this guy. And we also have a line of symmetry, again, where we fold one side over the other. And it's always x equals, and it's still the x value from the vertex, which is 3. And we've got everything we need. We've got our direction, our shape, our vertex, whether it says a min or max, what it is, a line of symmetry, and we've graphed our parabola. Okay. Let's keep our directions here, and let's do another problem. Okay, so again, we're going to use our template y equals a x minus h squared plus k. So the first thing we want to do is our direction. And our direction, as we can see, is up because the number in front of that squared quantity is a 1. Write it if you need to write it, okay? It's positive, so it goes up. All right, our vertex is what we need next, okay? Parens x minus, so our vertex is 2 for the x, and we don't have anything here after the squared quantity, so it's 0. We haven't added anything to it, so it's 0. All right, so we could also write our line of symmetry right now. X equals the x value from the vertex. We know it's going up, so we have a minimum point, and the value is from the vertex, it's the y. And shape. We know the shape is going to be the same as the parent because the value of a is 1. All right, so let's go to our vertex of 2, 0. So we move 2 to the right. We don't go up or down. It's going up. So we're going to go same shape, means it acts just like the parent. And remember, the parent is right 1, up 1, right 2, up 4, right 3, up 9. So let's do it. So right 1, up 1, use symmetry on the left. Right 2, 1, 2, 3, 4, use symmetry on the left. And let's go 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's go 9. and then draw yourself a nice parabola. Okay, remember to curve it. And there you go. And that's our parabola. Okay, and it has the same shape as the parent, it just moved. All right, let's take a look at another one. All right, believe it or not, this is in vertex form, but we're missing parentheses, that's all. So our a value is always in front of our x, in this case it's 1 again, so our shape is the same as the parent. Now, since nothing's being added inside parentheses, the x value for the vertex is 0. But something is being added after the squared term. That affects our y, so it's 3. Okay, now we can do our line of symmetry, which is x equals the x value from the vertex, so x equals 0. We know since it's going up, we have to look at our direction here. Our direction is up because it's a positive x squared, all right, so it's positive in front of it, positive 1a. And so it has now the same shape as the parent, line of symmetry, so it means it has a minimum value, and that minimum value is the value of the y from the point for the vertex. So let's go to our vertex, 0, up 3. Shape is the same as the parent, so right 1, up 1. Use symmetry on the left. Right 2, up 4. Use symmetry on the left. And we don't have room for 3, so we just, again, minimum of 5 points, and we're all set. Okay? All right. Now, let's try another. Make it a little bit more challenging now. We have y equals -2 times the quantity of x minus 1 squared minus 1. So again, we're going to use our template for our vertex form right above it this time. Okay. Our a value is equal to -2. So that tells us the direction, because it's negative, is down. All right. It's 2 times the squared quantity. So that means the shape is going to be narrow, because it's going to be grow twice as fast as the original parent. So it's a narrow shape. All right, our vertex can be gotten from our x, x minus h. So it's x, it's minus, it's h. So the x is 1. So it's the opposite of what you see in here. So it's positive 1. But the y value is exactly what you see out here. So it's -1. So our line of symmetry we can write right away is x equals 1. Okay, that's coming from our vertex. Because it's going down, we have a maximum value, and that maximum value is -1, taken from our y. And I think we have everything that we need now. So we're going to start graphing. Our vertex is at 1, -1, so it starts here. Now, let's take our parent parabola again and take a look at it. Our parent parabola says move 1 to the right and go up or down depending on direction 1. Move 2, move up or down 4 depending on direction. Well, we're going down, but this says go twice the amount we would go for the parent. We always move 1 away from x, and we typically go down 1, but this says go twice that amount, so we go down 2. When we move 2 away on the parent, we go down 4, but this says go twice the 4, so we're going to go down 8. 3, 4, 5, 6, 7, 8. And you can see that it's a lot narrower than our parent. And there's your nice parabola going downward with a vertex of 1, -1. And growing twice as fast as the parent does. And let's try one more. Again, always write your template. Our A value is negative, so our direction is down. All right, so we got that right away. It's a -1, so the shape is the same as the parent. So 1, 1, 2, 4, 3, 9. And our vertex is opposite of what you see inside, so +4. Exactly what you see outside, so +2. So from there we can do line of symmetry and write that right away. So x equals 4. We know since it's going downward, we're going to have a maximum point, and that max value is the 2. Okay, that's how high it's going on the graph. And I think we have pretty much everything we need. So let's go to it. 4, 2. It's going down, okay? And we're going the same as the parent, same shape. So 1, right 1, down 1. And do symmetry on each side. Right 2, down 4. And use symmetry. Just be careful. And try to hit those points. I know it's kind of hard. Don't make it look like a tulip. All right, and there you go. And there's your parabola. All right, so that's about it for graphing quadratics in vertex form.